Hi class, this is Professor Latham. I'll be doing a movie on finding the confidence interval for the difference between two means using the student t distribution. And let's move over the tab just a little bit so we can read the whole problem. The University Center has two main computers. The center wants to examine whether computer 1 is receiving tasks that require processing times comparable to those of computer 2. Random sample of 15 processing times from computer 1 showed a mean of 67 and a standard deviation of 15, while a random sample of 11 processing times for for computer 2 chosen independently of those for computer 1 showed a mean of 68 seconds with a standard deviation of 17. Assume that the times are normally distributed for each of the two computers and that the variances are equal. Let's make sure I read that. Are equal, and construct a 95% confidence interval for the difference between mu1 and mu2. Alrighty, so then let's go ahead and do that. So we're going to go over to list of formulas, and if you've already watched the movie on finding the confidence interval for the difference of two population proportions, you'll recognize that we went to list of formulas and saw that the estimate plus or minus the critical value times the spread gave us a formula for finding the confidence interval. So if I scroll down just a little bit more, you'll see that at the heading you have the estimate, and then you have the spread, also called the standard deviation or standard error. So you can almost imagine, if you will, that it's equal to the estimating statistic, x bar, in this particular case, plus or minus the critical value times the spread. And so if we scroll down on any of these formulas, it's going to be the same. X bar plus or minus the critical value times the spread. In this particular case, p hat plus or minus the critical value times the spread. So then let's go ahead and find our particular case, which is the difference between two population means where the variances are equal but unknown. So in our particular case, we have here that sigma 1 and sigma 2 are unknown, n1 and n2 large, and large is greater than 30. In our particular case, we had small sample sizes. And so this is the formula we're going to be using. Estimating a confidence interval for mu1 minus mu2, or testing or hypothesis testing. In our particular case, it's a confidence interval, and that's when the variances are unknown. That's what this symbol here is, sigma 1 squared. That's the variance of 1 squared. The population variance for computer 2 squared, excuse me, not squared. The variance means that it's squared, the standard deviation squared, but it's the variance of the computer 2, and we know that they're equal. So we're going to use this formula to find the spread. And it turns out it's a long formula. You can see here, this guy here is actually the spread, but we need that first guy in there. That's the pooled standard error, and that's what this stand here. So that's the pooled standard variance, I should say. And so we're going to first find this guy first, and then we're going to store it, and then we're going to use that information to find this one. And this indeed is the spread or the error. So now let's go back to our formula. It's always the estimating statistic, in this particular case x1 bar minus x2 bar, plus or minus the critical value times the spread. So this whole creature here is the spread, but we've got to do some intermediate computation first. So let's go ahead and click on the pooled standard variance and then substitute in. And so it pops up into the calculator. Yippee! We love that. And we know that we have here for the first computer we had 15, a random sample of 15, and then we had a random sample of 11 for the second computer. So let's go ahead and click on our N1 here and put on 15. And then the standard deviation for the first computer showed a mean of 67 and a standard deviation of 15. So the variance, the standard deviation and the sample size are the same for this one. And then we have here a random sample of 11 processing times, so the N2 is going to be 11. And pardon me, I made an error here. This stood for the standard deviation for the sample 2, and the standard deviation was 17, so let me change that 11 to a 17. Alright, so that'll give us the pooled standard error. And so we get 251 and some change. So we're going to store that value. And then we clear that. If we hit the recall button, there it is again. So we just love that. So now we're going to go back out to list of formulas so we can find the spread. So as I scroll down, and here we go. We've already computed this guy, and now we're going to go ahead and compute the spread. So we just hit recall, and that will input the pool standard error or pool standard variance right there. And the first sample was 15. Remember, it was the same as the standard deviation, and the second sample was 11. And here we had 11 processing times. And so that'll give us our spread. So let's go ahead and store that. And now we go back to the formula again. x1 bar minus x2 bar plus or minus the critical value times the spread. So for our first sample, we have here that we had a mean of 67, and then the second one we had a mean of 68. So it's going to be 67 minus 68 plus or minus the test statistic, the critical value, which is t. And for this particular case, we have, I think it was a 95% confidence interval. Yes, so we have a 95% confidence interval. So that's 0.05 in the tails, and when you divide that by 2, you get 0.05 divided by 2, or you can put in 0.025. Either way, you'll get the correct answer. And the degrees of freedom, there's a formula for that. You take the first sample, which is 15, plus the second sample, which was 11, and subtract 2. So you could take 15 plus 11 minus 2, and that will give you the degrees of freedom. However, we can go ahead and put that value in. 15 plus 11 is 26, and minus 2 is 24. So that gives us the degrees of freedom. Let's go ahead and hit tab, and that will take us out of the t value, that is the critical value, and then we're going to multiply that times the spread, and we go to recall to capture the spread. And so that will give us the formula for finding the confidence interval. So it's x1 bar minus x2 bar plus or minus the t value, which is the critical value, times the spread. And the spread we had to compute it first doing the pooled standard variance and then computing the spread. And so we come up with negative 13.99 and 11.99, which means in some cases you're going to have mu1 minus mu2. In other words, mu1 was going to be larger, where mu1 minus mu2 being larger. You say, what happens when you subtract a larger thing minus a smaller thing? It's going to be positive. Or there's cases where mu1 minus mu2 is a negative in this first case, and therefore mu1 is going to be smaller than mu2, because if you take a small thing minus a large thing, you'll get a negative number. So in other words, the difference between the two means could be hit and miss. Sometimes mu1 is bigger than mu2, sometimes it's less than mu2. So anyway, so let's go ahead and input those values. And so when we input those values for the lower limit, and I think they want us to round to 3 decimal places here, so yes. So let's go ahead and plug that value in. So the lower limit is going to be negative 13.997. Uh-oh. Oh, I see what I did. I put it in the calculator. And then the second one is going to be 11.997. And let's make sure I round it correctly. Yes, there's no terminal digit. Yes, perfect. Isn't that just a beautiful sign? We love very good. So let's do one more. All right, so we have researchers interested in determining the relative effectiveness of 2 different drugs. Treatments on a people with a chronic illness established 2 independent test groups. The first group was 9 people with the illness, and the second group consisted of 16 people with the illness. The first group received treatment and had a mean time of 166 with a standard deviation of 9, and the second group received treatment 2 and had a mean time of mean time until remission of 183 days with a standard deviation of, let's scroll over and see, of 5. Okay, so we're going to first go ahead and find the pooled standard variance. So we'll scroll down and find our S sub p squared, and then substitute the value in. So the first group was 9 people, and then the second group consisted of 16. So 9 and 16. So 9 and then 16 for the second group, and then the standard deviation for the first group. So the first group had a standard deviation of 9, and then the second group had a standard deviation of 5, so 9 and 5. And then we're going to store that, and then we're going to go out to list of formulas and now find the spread. Then we click on list of formulas, and then we place our mouse here and hit recall. And then the first sample was 9. So no, that's the standard deviation, excuse me. Usually I write down all the values on my piece of paper. I would say N1 was this and N2 was that. So in the first group we had the first sample, oh, it was 9. So N1 was 9 and N2 was 16. By the way, in that formula for the pooled error, I should have pointed that out when we found the S sub p squared. The denominator is always the degrees of freedom. If you notice, it was N1 plus N2 minus 2. Alright, so that gives us our value for our spread. So let's go ahead and store that. And now we can go ahead and compute the confidence interval. So it's going to be the first mean minus the second mean, and it says here that it was 166 days before there was remission, until remission in 183. So it's 166 minus 183 plus or minus t, and in this particular case we have a confidence interval %90 confidence interval. So it's going to be 0.05 because 10% is in the tails, and what's half of 10%? 5%. Think of money. Half of a dime is a nickel. And then the degrees of freedom are going to be, the first sample I believe was 9. There were 9 people in the first group and 16 in the second. So 9 and 16 is 25, and 25 less 2 is 23. And we're going to hit tab to get out of that, times recall. And that'll give us our two values. And they're both negative, which is great. Whenever they're both the same sign, that means when you subtract the means, you're going to get a negative number. So, well, what does it mean that if you subtract two things and it's negative? That means the first creature, the first population mean, must be less than the second. 2 minus 5 is negative 3. So the first creature is less than the second. And that means that we're 95% sure that the first drug is going to have a smaller mean than the second drug. There's a 5% chance that we might not be right, but we believe that the population means, when you subtract them, that their difference is going to fall somewhere between negative 21 and negative 12. So let's go ahead and input those values. And so when we do that, we get negative 21.762. And I think we're supposed to round our responses to, at least 2 decimal places. So 3 will work. Actually, 3 will work if you round it right. That would be, I'm going to change this to just 2. Otherwise, that should be 3. And negative 12.24. So if we here 237 is 0.24. Yeah, hot doggy. And Ah, I tell you, very good is a beautiful thing to see. You seem to have mastered this question. So I hope that this helps. If you have any questions, feel free to call me, Professor Latham, at 916-813-9027. Signing off. Have a great one. Bye-bye.